My name is Jatin, and today I'm representing my team GeoHero on this stage. So we came across this problem, AI-based rockfall prediction and alert system for open pit mines under the theme disaster management by the Ministry of Mines under the category software. So without further ado, let's get started on understanding what rockfall actually is. So, rockfall is the sudden falling of rocks and debris from a steep rock slope by when soil is loose. So, loose rocks or soil break away from mine benches. So here, as you can see, this is an example for from a coal mine in Jayant, Jharkhand. So these are the benches, mine benches. These are crashed and these are doors. So if rocks and soil break away from here, this might cause a rockfall, just like that, as you can see here. So so now we have to understand why rockfall is a problem because human lives is at a risk. So if a worker working on a mine, if and a rockfall happens, their lives might be in danger, and then there's an operational disruption. So mine can shut, all the operation might disengage, and uh, equipment and might be harm, might be damaged. So it causes economic losses and loss of revenue because of that, right? Also, environmental effect. So a rockfall can also have a long-term environmental consequences if it disturbs natural vegetation or something like that. It might cause soil erosion and all those stuff. So now we know what is the problem. Why is it a problem? What is a rockfall? Now we have to understand how can we prevent it. So before diving into how we can prevent it, we have to make sure have to understand what the problem actually is, what we have to solve to predict rockfall. So as an ML engineer, we should have a clear understanding of a problem statement. So this is the problem we have to solve, that is bench stop instability. We have to find out how steep the bench is, it is eroded, is it irregular, which might fail and cause rockfall, and then we have to find out if there is a drainage or water accumulation, poor runoff, and or water saturation increases the slope, this failure, and then we have to figure out is there what is the natural nature and environment is like. Is there heavy rainfall? What is the blasting and drilling schedule? Is there vibration or earthquake prone area? We have to know about the soil condition. It is the most important factor. We get to know about them with sensors and other things. So these are solution. So we getting the drone images and we are converting them into ortho photos. We getting sensor data. So we using the ortho photos for getting the slope, curvature, elevation, surface change, and cracks and something like that. And then we using IoT sensors to getting the displacement, pore pressure, and vibration, like all the soil condition. Right. Then we have a weather API to getting the rainfall, temperature, all those kind of stuff. And not only that, we also make a count of historical rockfall data to identify the pattern and the calibrate, taking them as a benchmark and calibrating the risk accordingly. We using a hybrid ML pipeline. We using DINOv3, a computer vision model, to get the visual cues from these visual data, and then we training the exhibits to understand and to predict um, the probability, analyze the sensor data and predict the probability of rockfall. We fusing these embeddings, these information from both of the model into a click-based model for analytics and more clear understanding by combining the visual and tabular feature to compute the stability score per bench. So whole mine is divided into some patches, and then we are calculating the prediction for each of the patch, right? So we get a holistic idea, holistic probability, holistic risk level, and then we using those information to visualize them on a dashboard using React and MapLibre and other visualization libraries. So DINOv3 is a state-of-art model in computer vision, and it is self-supervised learner. So we don't need a lot of data set to train our model. We can give them as some references, and it will learn automatically from that. Right? This is a technical approach how we are collecting the data, how we are feature engineering them, which are the features that we are selecting, then preparing the data, and then there is a training pipeline. We using time-based splits, right? Then we have a hybrid ML model pipeline, right? And then how we are showing the output, we giving a real mask as a shape file that can be visualized in QGIS. Then we are automating alert with recommended preventive actions, and we have a interactive map-based dashboard made with React and MapLibre using Fast API as a backend, right? How is our solution feasible and viable? We using open source tool like DINOv3 and Exibus, and we using cloud development Railway, which is rapid for prototyping. And going further, we will use EC2 and S3 for storage, and EC2 for instance compute, right? Scalability. So our whole pipeline is site agnostic. It can be used in different mining sites without making a lot of changes, right? Then there is a synthetic and real world data. So most of the potential challenge that we have faced is limited real mine data. So we are using a synthetic annotation of the real data that we had. So we're using NASA's Landsat catalog and Google Alpha Earth with our self-supervised model like DINOv3 that need very less data to get its reference from. Then the other problem is ML model usually give false positive and negative. So we are not completely depending over the ML model's prediction. We're using ML with rule-based threshold and regular model calibration, right? Then the impact and benefit. So how is it benefiting the mine planners, field worker, and mine companies? So mine planners get the prediction insight of the mishappening beforehand, and they can plan and enable decision making according to that. Field worker, it saves their lives, right? Mining company, it manages, it optimizes the operational downtime and reduces the costs, right? Government regulators, so it improves the safety, compliance, and disaster management efforts. Social benefit, it saves the lives of humans. Economic benefit, it reduces the downtime, cost from equipment damage. Environmental benefit, prevent large scale slope collapse that can damage whole ecosystem, right? And research and references, we using Google Alpha Earth embedding and Open Meteor API for weather data. And then we have this NASA's Global Landsat Catalog. These are whole research papers that we came across. And this is a demo that we have made. So here you go. This is the Rockfall Rockfall prediction system. These are the active sensors. These are high risk zones. Okay, and this is the giant Minecraft live risk zone map. This is all it. So we have recent alerts, all the sensors that are active, we get the current reading, users that are active on our system, their activity we can log here. uh, we will make a holistic data pipeline, but for now user can drop their data, and yeah, these are the format of that data. They can analytics, so they get all sensor based analytics, what are the prediction, what are their readings and all this kind of thing. And there's a risk report they can download, uh, the shapefile of the risk map, and they get risk matrix as well. Then they get a AI assistant that they can talk with and understand how it actually works. So yeah, so this is it. My name is Justin and I'm signing off. Hope you guys like it. Let us know.